Question number 6. A 10-bit DAC has a step size of 10 millivolts. What is its full scale output voltage and the percentage of resolution? This question is straightforward. We can solve it easily. So before going to solve this question, let us learn few formulas. First one, full scale output FSO is given by 2 power n minus 1 into step size. Second one, percentage of resolution is nothing but step size by full scale output into 100. So using these two formulas we can solve this question easily. During extension I'll explain you elaborately what is step size and what is resolution. So on considering this first formula, FSO full scale output is nothing but 2 power n minus 1. N indicates number of bits of the DAC. Here it is given that it is a 10-bit DAC, you can see. So 2 power 10 minus 1 into step size. Step size is given as 10 millivolts. On simplifying this, you will get an approximate answer of 10.23 volts. Next, percentage of resolution. This is nothing but step size. Step size is already given 10 millivolts divided by FSO. FSO is 10.23 volts. Volts and volts gets cancelled into 100. So on simplifying this, you'll get an approximate answer as 0.1%. So the right choice is option C. Extension. Let us see few concepts related to DAC. So DAC is a digital to analog converter, DAC in short form. So let us see two terms. What is their physical interpretation, which is quite common in any exam to relate this type of questions with a physical scenario. So let us see what is step size. Step size, for your kind information, step size is same as the resolution. Step size and resolution are same, but percentage of resolution is different. I'll come to know after this. Let me explain you what is a step size. So consider a DAC. Now you might have already understood what a DAC does. DAC is nothing but it takes some digital inputs. And it produces some analog output. I'll give an example by which you can understand easily what is a step size. Consider a 3-bit DAC. 3-bit DAC means the digital inputs are of 3 bits. Assume the input is 100. So it makes the output as 4. This is the operation of DAC. Suppose I changed 1 bit, the last bit of the DAC, that is I made this as 101, the next bit, the next change which occurs, then it should be 5. So for 1 bit change, whatever the difference in between this analog voltage, this is nothing but 1 volt. This is nothing but step size. That is, in general, suppose if there is a DAC and say this is the digital inputs, say for one input 100000 whatever, and the next input is assume, just I replaced the last digit with 1. So for the first time, all 1 with all zeros, assume the output is x. Second time, when you replace the last 0 with 1, assume the output is y. These are two different cases I am showing on the same DAG. The difference between x and y, x minus y, is nothing but step size. This is nothing but resolution. So I think you have already understood now what is step size. Step size is the smallest change that has occurred for a 1 bit change in the input. For a 1 bit change in the digital input, whatever the difference we are seeing it at the analog output, the difference in the analog output is nothing but step size. So step size is simple. Now let us see what is this full scale output. Full scale output. Before going to FSO, let us see how an output of DAC is calculated. DAC. Assume if it is a 3 bit, if I say 100, then you will say immediately the output is 4. Provided the step size should be 1. If the step size changes to 2, then the DAC is, this is for step size equal to 1. Suppose if step size is changed to 2, then the DAC output is no more 4, it changes to 8, because it needs 2 steps, 2 times, 2 folded. So in general, the output of the DAC, this is a very important formula, is given by analog equivalent or decimal equivalent, whatever. So analog or decimal equivalent of binary input or digital input, binary or digital input, this multiplied with step size. This is a very important formula. So using this you can solve many problems. Okay, so he'll be giving a binary input or digital input, he'll be asking the output for a given step size. This is the first formula. Second formula is FSO, full scale output, means all inputs are full scale output. Assume it is a 3-bit DAC. For the same example, I am taking 3-bit DAC. Instead of this inputs, I am taking 1 1 1. So assume step size as 1. So what is the output you are going to get? The output we are going to get it as 7, which I can write it as 2 power 3 minus 1. Suppose if there are 4 inputs for a DAC, 4 input DAC, let us consider. All inputs you take it as 1. Then the output for a step size of 1, the output I am going to get it as 16, which I can happily write it, sorry, 15. Happily I can write this as 2 power 4 minus 1. So this output, whatever you are getting for all inputs as 1 or high, is called full scale output. Full scale you are measuring means all the inputs are high. For a full scale, complete scale, if all inputs are high, what is the maximum scale you have at the output? There is a meaning. So the formula is given by same analog or decimal equivalent of binary input. Okay, so what is the decimal equivalent of this 7 or 15? I can write it as, in general, 2 power n minus 1. So I'm able to write 2 power 3 minus 1, 2 power 4 minus 1, 2 power 5 minus 1, so on. So for n input bit, 2 power n minus 1 into step size. In this way FSO has been derived. So you know what is FSO, what is V out. Now one more formula is percentage of resolution. This is nothing but resolution divided by FSO. This is same as step size divided by FSO. As I already told, resolution and step size, they are same, equal. So try to memorize these 3 formulas. You can do any question. Thank you.